C34 Jan 2019, question 10. Figure 3 shows a container in the shape of an inverted right circular cone, and it contains some water. The cone has an internal radius of 3 meters, a vertical height of 5 meters, time t seconds. The height is h, the volume is v. The water is leaking from a hole in the bottom of the container, concentrated 0.02. And we've got to show this h squared dh over dt is minus 1 over k pi. That's the r of the water, the radius of the water, which is also a cone. Tells us the volume of a cone. So the volume of water is 1/3 pi r squared h. It's leaking at 0.2 meters cubed per second. So dv over dt is minus 0.02. I'm going to look at these dimensions as well and find a relationship between h and r, because I want to lose all the r's really. R over h is equal to 3 over 5, similar triangles. And I've got dv over dt here, but I want dh over dt, so I'm going to connect them like this: dv over dt, dv over dh times dh over dt. And then so looking at these two, like I say, I've got no r's in here, so I can eliminate the r by writing this. R is 3/5 h, so the volume is 1/3 pi r squared h, 1/3 pi r squared h, and that simplifies down to 3 over 25 pi h cubed. The dv over dt is minus 0.02. So I can write this as minus 0.02. Now I need the dv over dh. I've got v in terms of h here. So the dv over dh, just differentiate this. The 3 will go in front. So it'll be 9 over 25 pi h squared. And then the dh over dt, stick on at the end. And if I'm nearly there then, because I've got h squared dh over dt. I'm going to divide by the pi. So the pi ends up on the bottom. The fraction though, it'll be 25 times 0 minus 0.02, which is 0.5 over 9. That comes out to be minus 1 over 18 pi. You could differentiate implicitly by doing dv over dt. We've got the v in terms of h here, so differentiate in terms of h just like before. 3 times 3 over 25 times h squared multiplied by dh over dt. Put the minus 0.02 in and you get the same result. So I've got the differential equation now. I've got to express h in terms of t. So I'll separate the variables, h squared dh, and then put the dt up here, and then integrate both sides. This is going to be h cubed over 3. That's just a constant, so minus 1 over 18 pi times t, and plus a constant. Now it said initially it was full. So when t is equal to 0, the h is equal to 5. Sticking those in, the c comes out to be 125 over 3 because this term's 0. So putting the c in there, we'll have 125 over 3 minus this is 8 cubed over 3. So multiplied by 3 and cube rooting it, I get h in terms of t. Then the time taken for the container to empty, we want the h to be 0, so 125 minus t over 6 pi is equal to 0. 6 pi times 125, 750 pi seconds, which is about 39 minutes.